So now let's take a question to understand what we have seen or we understood in the previous video. Randomly we are going to take any two equations. So let the equation be 2x plus y, 2x plus, I will say 1y, better, 2x plus 1y is equals to 3, and then 1x plus 2y, 1x plus 2y equals to 6. Okay, now in the previous video you have seen that coefficient of x we write in a matrix. Again we are going to name it as A, and if you see over here, coefficients of A will be written in a matrix of order 2 times 2. So I am writing the first row 2 1, and then the second row I am writing 1 2. Then the variables, we are going to write variables in another matrix and say the matrix is x, and the variables are x and y. So x here and then y here. Now we are left with the constants given on the right hand side. I will use eraser. Now say the matrix, another matrix is B, and then I will write B in the another matrix whose order will be 2 times 1, that means 2 rows and 1 column. I can write them as AX is equals to B, AX is equals to B, which will implies to us as X is equals to A inverse B, A inverse B, A inverse times B, you can say. Okay, now whenever we are going to solve any question using system of linear equations using matrices, first thing which you should do is, the first and most important thing you should do is, you need to find out determinant of A, which we have done in the previous classes. You need to find out determinant of A. Now how to find out determinant of A? We will multiply elements of principal diagonal. This is called the principal diagonal, the diagonal where position of column and row, or you can say A11, A22, A33, like that. The number given for columns and rows is same, so that is called the principal diagonal. So we will multiply elements of the principal diagonal. So you can see over here the elements in the principal diagonals are 2 and 2. So I will multiply them. 2 times 2 minus, then you have to subtract, and then you have to multiply elements of the other diagonal, which is 1 times 1. I am going to write 1. So if I'll solve it, so 2 times 2 is 4, then minus 1, I am going to get 3. Now as determinant of A, which we found is not coming equal to 0, so this matrix A is called non-singular matrix. This matrix will be called non-singular matrix, A matrix whose determinant is not equal to 0 is called a non-singular matrix, and inverse of a matrix will be possible only if the matrix is a non-singular matrix. For singular matrix, determinant will be equal to 0 and inverse will not exist. So now we are very lucky that for this matrix, determinant is not equal to 0, so it is non-singular and its inverse is also possible. So let's find out inverse of it. Now that I am going to put in step number 2. So step number 2 is coming on your way. So let's write it. Now this finding A inverse also we have done in the previous classes. Now how to find out? Whatever is the determinant of A, I am going to write it in the division. So determinant of A was 3, so I will write it as 1 over 3. Then this matrix is of 2 by 2, so we have done in the previous classes the short trick to find out A inverse. What we are going to do, we are going to interchange elements of principal diagonal. Luckily elements of principal diagonals over here are same, so there will be no change basically. So I'll write 2 and 2 first, and then elements of other diagonal we are going to multiply with negative, with minus. So 1 will become plus 1 will become minus 1, and here also plus 1 will become minus 1. So this is the inverse. So this is step number 2, where you're going to find out inverse of the matrix. Now the most important step, where we are going to find out value of x, and that is going to come by A inverse time B. So first I am going to write A inverse, so which is 1 over 3, 1 over 3, then the matrix, so this is minus 1 and 2, and I am going to write B matrix over here again because I have to multiply them. Okay, now I'll just go to the next slide to complete this multiplication. I'll just go to the next slide. So we are on the next slide. I'll write this multiplication over here, x, and then I'm going to write 1 over 3. Okay, now I will write it again for you, 2 minus 1 and minus 1 and 2, and then I will write matrix B, and matrix B is 3 and 6, 3 and 6. Okay, now let's do the multiplication. Let's do the multiplication. So I will write x here, and the next step implies this one, so I'll put sign of it implies that. I'll write 1 by 3 as it is, 1 by 3 as it is, and then I will multiply. If you see, order of resultant matrix will be 2 times 1, so first row will be multiplied to first column, and the corresponding elements means the first element will be multiplied to the first element, and the second element will be multiplied to second element. So first I'll multiply 2 and 3, so I will write 2 times 3, then plus minus 1 times 6, and then second row will be multiplied to the first column, so it will be minus 1 times 3. We are multiplying corresponding elements, plus the second element is 2, and in the column second element is 6, so 2 times 6. Okay, so now I'm going to write x again in the matrix form. So we can write x as small x, and in the second row first column it is y. So now the simplification, so I will just simplify it. I need to write it again, 1 over 3. Okay, if you just see over there, 3 times 2 is 6. 6 minus 6 will be 0. This is minus 3 plus 12. Minus 3 and plus 12. So it is going to come 9 over here. 9. And if I simplify, so I will get x here, y here, and if I multiply 1 by 3 inside, I am going to get 0, and I will get a 3, which means the value of x is, if I compare both the matrices, x is equals to 0 and y is coming 3, and y is 3. So this is how we are going to solve system of linear equation using matrices. I hope you understood this, and you all know that practice makes men perfect.